Welcome. This is the section where we look at how we build the Streamlit fraud detection dashboard. So as a reminder, we've got a threshold here that has a default setting of 50% for our baseline classifier. And the intention of the dashboard is for us to simulate different thresholds and to see what the impact of different thresholds are on the model from a cost perspective, as well as from a classification performance perspective. So what I'm going to do is I'm going to change this threshold to something like 80%, where basically any probability of being above 80% gets classified as fraud, while any class probability of being fraudulent below 80% gets classified as non-fraudulent, right? Then we also have access to a cost calculator where we can input costs for the different classifications with the purposes of creating a total cost of fraud, both for the default classifier as well as for the updated classifier, whose threshold we set with this toggle. All right, so I'm just going to input some scores for false positives, true positives, etc. And what's nice with Streamlit, you can just insert the number. You can use the plus and minus to add or subtract values, and just enter on the widget afterwards, and it'll recalculate your total scores. Right, then further down at the bottom, what I've got is the data frame that contains all of the scores as well as all of the classifications, etc. for both models. So we can see here that the new updated model has a threshold of 80, where the baseline has a threshold of 50. And then we can also see the classification performance metrics. So the AUC score, we can also hard code a cutoff score if that's what we want to see from an operational perspective. We've got the average precision score, which is the area under the precision recall curve. And then not using, more technical jargon. So we're not calling these false positives, true positives, etc. Rather, we are explaining what it actually is from a business perspective. So the number of fraudulent transactions detected, etc., for your true positives and so on, as well as the total number of transactions that were assessed, which is basically the total size of our testing set. Then if we compare the two models, we can see that the default cost is 29,100. And then if we dial up the threshold on the updated model to 80%, then we see the total cost of fraud does increase slightly. So that would be a less optimal solution. So I guess based on this, we would select the default classification threshold, but that wouldn't be the case for all models. In certain scenarios, this would be useful. And it also allows you to impute different costs to simulate different scenarios from a business perspective, which can obviously help with planning and other things. Then if we want to see how to implement this within Streamlit, I've provided two scripts where effectively I've got a secondary module that I've created myself, which is this Python script over here, which just takes a data frame as input and then calculates the classification scores using scikit-learn. Right, so things like ROC score, the average precision score, it puts it all into a data frame and then prints out the data frame that we see at the bottom of the dashboard. And then it also makes the classification decisions based on the threshold that we provide as input. So it receives the default threshold and then also the threshold that we imputed as part of that toggle selection process. Right, then Streamlit we also need to install locally. So using pip install Streamlit, pandas and numpy, we've been using that a few times throughout the course. Then this section over here, we're just reading in the CSV that I've saved. In a previous lesson, we looked at saving both the target variable as well as the score or the class probability of being in the fraudulent class. Save that to a CSV locally. Just make sure that you've got access to that same CSV within the same location that your two Python scripts are in. And then you can run everything together and it should automatically upload that CSV and then continue with the process. Then this is the logic to create the slider. We've also set a title for the overall dashboard, so we're calling it fraud detection dashboard. The slider, this is the logic that we're using here. We've set up a default value. We've got the min and the max, as well as the different steps, so the increments that you can select. Then this is the step where we're actually calling this get metrics data frame function, which is the secondary one I spoke about. It supplies the threshold that we set from the slider as input, as well as the data frame which we've loaded from our local directory, and then it returns basically what we use to populate the data frames later. Then this section over here is our input box for costs, and then what we do is we display the total cost of fraud based on those costs. Then we split things into two tranches, one being for the default classifications and then one being for the updated classifications. So the logic is largely the same. We've just made a distinction between the two, where initially we initialize some counters for the different classifications. So, the number of true positives, false positives, etc. We've initialized those to 0. Then we iterate through all of the rows within the threshold data frame, and then we just make comparisons between the target variable and the classification decision. And then if that condition is met, then we increase the counter, effectively building up our number of classifications in the same way that we do from a confusion matrix perspective, where we work out what the count of elements are within each of the quadrants. Then we sum those together along with the inputs for the costs that we've taken from the dashboard, and then we've created the total cost of fraud and we write that out to the dashboard. So that was for the default model. Then for the updated model with the classification scores that are derived from the updated threshold, we followed the same approach. Ultimately, we write the scores back to the data frame over here. Right, then the last two steps, what we do is we explicitly create those data frames where we've got all of the performance metrics as well as the number of fraudulent transactions, where we explain in plain English what each of those classifications mean. And then in order to run everything together, we need to put our files into a directory together. So we've got the app.py file, we've got the eval.py file, then we've got the error.df.csv file. So we just need those three together. We need Streamlit to be installed on our local Python instance. And then we can just use our command line to access that folder and then just run Streamlit, run, and then app.py. And then everything should run. It should open up in your browser, and then you should be able to run the full demo.